Hello everyone, thank you for joining us back. We are continuing our web series Unwrapping Docker. In the previous video we learned and understand the Docker architecture, and we also see how Docker communicates. So it's time to learn internals of a Docker. So before we learn and understand the internals of Docker, first we need to understand internals. What are internals? So internals is something you can relate it to the pillars. So imagine you are supposed to build a building. So the fundamental things you require to build or stood up your building, that is internals. So pillars, roofs, beams, and walls, all these are the basic fundamentals required a building to be stood up and looks like a building. So internals is something that actually fundamentally make a thing to be visualized as it needs to be. So Docker has some internals. There is no doubt Docker takes advantages of several features of Linux kernel to deliver its functionality. So that is very true statement. So we will see how those or what are those in components. So first, kernel namespace, C groups, IP tables, and storage plugins. Kernel namespaces, we will discuss each individual item one by one. So in each component we will see in detail how they function and how they are being utilized by our Docker engine. So first, namespaces. Before we jump into directly into the namespaces discussion, what we need to understand is what actually namespaces are. Linux namespaces are feature provided by the Linux kernel that allows for the isolation and virtualization of various aspects of a system's resources. Imagine you wanted to create some logical boundaries between the memory and the processes. It gives you a way to create multiple virtual resources, virtual instances, we normally may called containers, on a single Linux machine. Each namespace provide an isolated environment for a specific resource. Let's say I wanted to create a logical boundaries between the network. I wanted to create a logical boundaries for my storage. I wanted to create a logical boundaries for my network information system. So all these being handled by namespaces. All those logical division of a system resources being handled by namespaces. So let's understand what are the namespaces being used by Docker engine. So Docker engine uses the following namespaces on Linux. The first namespace is PID namespace. This is for the process isolation. So imagine there are some processes running, so it must be run in isolated environments. This is the main concept of Docker engine. So Docker engine gives you isolation. So whenever a Docker container being created, it creates several namespace. The first namespace is PID namespace. So it ensures every individual process that runs in different or separate container should not be interact with each other. So PID namespace ensures it. Then we have a net namespace. This namespace is actually for managing the network interfaces. So whenever we create Docker container, it creates a network interface, and net namespace ensures the network communication, isolation, and security as well. Then we have a IPC namespace. It's also known as interprocess communication. So whenever a process or resource requires to interact with each other, so IPC namespace comes into the action, and it ensures secure and smooth communication between the processes. Then we have a MNT namespace. It actually manages the data layer. You can say it actually manages the data layer. It manage the file system, it manage the data with which going to be reside under the Docker containers. So it ensures the logical division between the Docker container storages. So whenever a Docker container spins up, it also spins an MNT namespace. UTS namespace for isolating kernel and version identifiers. So let's see in real world. We already discussed that this particular video series is more focused towards the hands-on, so we will see how things works. So we are saying this is the first step that we are working with the Docker namespaces. We are saying that whenever we spin up a Docker engine, Docker container, it creates several namespaces. So it's time to prove whatever we are saying. So let's directly jump into the by the way, I already written every single steps, so you can capitalize my slide deck. So without wasting any time, I'm just directly jump into the my server console. So this is my server machine. I ensure that Docker engine is installed. So yeah, my Docker engine is installed. If I say Docker PS, nothing is running. So just before this slide, we were saying whenever we create a Docker container, it creates several namespaces. So let's create a Docker container, and then we will visualize which namespace is being created when a Docker container runs. So that's docker run space minus it space minus d minus minus name is just a command that actually spins up a Docker container. So I'm saying web1, and I'm using nginx. So it creates a nginx container. If I say docker ps, so yeah, it's there. So next thing I need to because we also said that in our previous video that what is Docker? Docker is just a Unix process. So it's time to prove what we have said. We said Docker is just a Unix process. So we whenever a Unix process spins up, it spins up with this its process ID. So let's find out the process ID of the Docker container. So we have a command called docker inspect, and we need to do some advanced. Don't worry about. I'll be putting these commands in the description, so you don't need to worry about how you wanna reproduce or state. Sorry, I'm just making some mistake. State.Pid, and then we need to use the container ID. What I'm doing is I'm just trying to find a process ID of this particular container which I called y1. So I just copied. So this is the process ID of my Docker container. If I say psaux pipe sign grep and the process ID, so I will see all the processes being consumed by this specific. So you can say there is a nginx process already running. Now we also said that whenever Docker container spins up, it also spins it also creates some namespaces as well. So we have a command called lsns that also known as list namespaces. It will show all the namespaces for a specific process ID. So this is our container process ID. We already got that. So now it's time to see which namespace is being created. So lsns minus minus task and the process ID. So it shows me there are several namespaces being created when I stood up a Docker container. So there are some C groups being created, and the user namespace. This is the namespace ID, MNT, UTS, IPC, PID, and NET. These are the namespaces, and these are the processes that actually consume these namespaces. So 21082, this is the process ID. This consumes MNT, UTS, and all those. So hence we proved whenever container spins, it creates namespaces. Imagine if there is no Docker engine, are we able to access, like imagine you don't have this Docker CLI tool to interact with your Docker container. So we can Linux enables us to connect with each individual namespaces. We can connect to MNT namespaces as well, UTS namespace as well. So there is a command called NSenter that actually enables me to access the or enter into the specific namespace. NSenter and then minus minus target. In the target, I need to mention the process ID on which namespace I want to access. So this is the container process ID is the target. So what I am saying, connect me to the process ID 21082, and I wanted to connect a process namespace of --PID. So that's how I'm able to access each individual namespace. But if you really wanted to access the all namespaces which being created, so it's pretty easy to access NSenter --target --all. So this will actually connect me to the all namespaces that's being created by the Docker engine. It should be all, I believe. Sorry, I forgot to paste the process ID. So NSenter state. Okay, user failed, no such file or directory. So there is another way. All is not working, so what I can say is connect me to mount --uts --ipc -net -pid. So you can see my prompt has been changed, and if I hit psaux, ps command is not found. What I need to do is I need to install ps command first, -cat. First I need to update which tool, ps proc ps apt-get installed proc ps. This will install the ps command for me. Sorry about little hassle. So you can see psaux. If I hit the psaux, you can see the Nginx is running. So I entered into the container using NSenter. Now I will prove the same, that whatever I access, it's actually a container that we just created. So docker ps, sorry, exact, let's see what's the name. Docker exec space -it web1 and bash. So you could see the same prompt which I have when I access through NSenter command, and I got the same prompt when I access the docker exec command. If I hit psaux, so I will see the same processes that I used to have in my previous. So let's take a fresh. This is the docker exec command. When I hit when I ssh in directly to the container, I got these processes. Now I'm just popping out from the container, and I'm using my NSenter command. In NSenter command, I'm saying get me to the process ID, get me to the namespaces of process ID 2108. Which namespaces? --mount, -uts, -ips, -net, and -pid. And certainly you see the same prompt which we used to see in above when we execute the docker exec. Now we need to issue a command psaux. So you will see the same processes is consumed. We also said the process isolation, so it's time to prove the process isolation as well. We have a container with running with Nginx. Now I'll be spinning up a container, so we will ensure the both container process cannot see each other. Docker run space -it space -u -name Apache, and I'm saying Apache, Apache 2 HTTPD. Image name must be HTTP. I'm not sure. Yeah, it's HTTPD. It's Apache in Docker image. So we will see. We have two containers running. One is Apache, one is Nginx. This is the base command. Previously we access first we will see the web one, which is the Nginx one, and we will see which processes are being consumed. So we entered into the PS AUX. So we are able to see the processes that is specific to the web 1 container. If we SSH to the other container, which is Apache, so let's see what we will be seeing. Again, ps command is not found, so apt-update. Get install propius. So you see, at this prompt I'm not able to see uh, Nginx processes, and if I exit from here and I SSH into the web server container, and I'm not able to see the Apache ones. So this is something we were talking about, the process isolation. So each container cannot see each other, like a container cannot see each other, or in other words, they can't interact. But if I go to the base machine, I'm able to see both the processes, PSAUX. So you could see I'm able to see Apache, and I'm able to see the Nginx as well. So a base machine can see the process running under the container, but container cannot see what is running on the other container. So this is something we already proved, and this is the same. This happens because of the namespaces. Because container capitalize the namespaces, that is why they cannot see each other. They are running in the isolated world. They don't know, Apache container don't know there is an Nginx container is running, and the vice versa. So they cannot see each other. So this is something actually happened due to the namespaces. I hope this gives you enough knowledge about the namespaces. In the next video, we will cover the rest of the internals of the Docker. Till then, keep watching, keep learning, and thank you for watching for this video. If you don't subscribe our YouTube channel, please do subscribe and do share, and don't forget to like this video.